Good morning, students. Today I am taking some questions from exercise 6.3 related to increasing and decreasing functions. Here from exercise question number 6. Here find the interval in which the following function are strictly increasing or decreasing. I am taking one part of it, that is C part. Minus 2x square cube minus 9x square minus 12x plus 1. So consider it at fx. Fx is equal to minus 2x cube minus 9x square minus 12x plus 1. Now first step is to differentiate both the sides. So differentiating it both the sides with respect to x, we get d upon dx of fx is equal to d upon dx of minus 2x cube minus 9x square minus 12x plus 1. Differentiation of fx is equal to f dash x is equal to, now differentiation of left hand side, that is you take minus common and then differentiate it. 6x minus bracket 6x square plus 18x plus 12 minus 0, which is equal to minus 6, take common, it is x square plus 3x plus 2. Now factorize this, you get f dash x is equal to minus 6x plus 1 x plus 2. Now next step is put f dash x is equal to 0, we get minus 6x plus 1 x plus 2 is equal to 0. Solving it, we get two values of x, those are x is equal to minus 1 and x equal to minus 2. Now take number line and represent these two values of x on number line systematically. It will be represented like this: minus 1, minus 2 and minus infinity plus infinity. So possible intervals are minus infinity to 2 minus 2 and minus 2 to 1 and minus 1 to infinity. These are three possible intervals. Now you have to check in these intervals f dash x. So in interval minus infinity to minus 2, we take x belongs to from this interval, then the value of f dash x will be equal to minus 6 bracket x plus 1 x plus 2. If we take values from minus infinity to minus 2, means the negative values and negative side less than minus 2 value, just like minus 3, minus 4, etc. And you have to check this f dash x. Now you have to write only the sign of the solution, as you have minus 6 has negative sign. If value is from minus 2 to minus infinity x, then it will x plus 1 become negative. Suppose you may take x is equal to minus 3. Minus 3 plus 1, that is negative. And x plus 2, here minus 3 plus 2, that is also negative. So we have three negatives, minus, 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 and our multiplication of these all three is equal to minus. It means it is less than 0, so the function is decreasing. Again we take x from minus 2 to minus 1, from this interval minus 2 to minus 1. So f dash x, we have minus 6 x plus 1 x plus 2. So if we take such values minus 1 to the values from minus 2 to minus 1, it means the values are less than minus 1 but greater than minus 2. So we put the sign of the calculation. Minus 6 has negative sign. X plus 1. X plus 1 means you are having the value negative side of minus 1. So x plus 1 will give you negative. X plus 2 means the values are more than minus 2. So x plus 2 will give you positive value. So minus into plus, it will give you positive sign which is more than 0. So function is increasing in this interval. Again we have third interval, that is minus 1 to infinity. So if x belongs to minus 1 to infinity, we have to check f dash x, that is minus 6 x plus 1 x plus 2. Here we are having the values of x more than minus 1. So here we put the sign minus 6 as minus sign, x plus 1 will have positive sign because the values are more than minus 1. So x plus 1 will give you positive sign. Again x plus 2 will also give you positive sign. You may take minus 1 to infinity, any number from minus 1 to infinity, and then check the sign of the result. Then you will get minus into plus, that is minus. So function is decreasing in this interval because it is less than 0. Hence answer will be function is increasing in interval minus 2 to minus 1 and decreasing in interval minus infinity to minus 2 union minus 1 to infinity. We may take another question from the exercise. Show that function log 1 plus x minus 2x upon 2 plus x is greater than minus 1 is the domain, is an increasing function of x throughout the domain. So consider it fx is equal to log 1 plus x minus 2x upon 2 plus x. Differentiate it with respect to x, we get f dash x is equal to differentiation of log 1 plus x, that is 1 upon 1 plus x minus now here apply quotient rule. So we will solve 2 plus x d upon dx of 2x minus 2x d upon dx of 2x plus 1 whole 2 plus x whole square. So f dash x is equal to 1 upon 1 plus x minus 2x plus 2 plus x into 2 minus 2 into 0 plus 1 whole upon 2 plus x whole square. F dash x is equal to 1 upon 1 plus x minus, after solving it we get 4x plus 2x minus 2x whole upon 2 plus x whole square. Thus we get f dash x is 1 upon x plus 1 minus 4 upon 2 plus x whole square. So after solution we get f dash x is equal to 2 plus x whole square minus 4x whole upon 1 plus x into 2 plus x whole square. Thus we get f dash x is equal to x square whole upon 1 plus x 2 plus x whole square. And we have interval x greater than minus 1, that is x belongs to minus 1 to infinity. If we take minus 1x from minus 1 to infinity, we get x square upon 1 plus x upon 2 plus x whole square will be always positive. You may take any value from this interval and check this. You will get it is positive, so function is increasing in this interval. Now I am taking an example from your text, that is find the interval in which the function given by fx is equal to sin x plus cos x where x belongs to 0 to 2 pi is strictly increasing or strictly decreasing. You have take fx is equal to sin x plus cos x. Now differentiating both sides, we get f dash x is equal to cos x minus sin x. Now first step is put f dash x is equal to 0. If we put f dash equal to 0, we get sin x is equal to cos x. And now dividing it by cos x, we get sin x upon cos x is equal to 1. That means tan x is equal to 1. Now you have tan x is equal to 1, and you have to check all the values of x uh, within 0 to 2 pi. Within 0 to 2 pi, tan x will have positive value in first quadrant and in third quadrant. In first quadrant, angle will be pi by 4, and in third quadrant, angle will be pi plus pi by 4. Both are belonging to 0 to 2 pi, as it is given domain. Thus we get x is equal to pi by 4 and minus 5, and 5 pi by 4. Now represent on number line. You have 0 to 2 pi, the boundary, and pi by 4 and minus pi by 4, there are two numbers. So possible intervals are 0 to pi by 4, pi by 4 to 5 pi by 4, and 5 pi by 4 to 2 pi. Now from every interval we have to take x and check f dash x. In interval 0 to pi by 4, we have to take x belongs to 0 to pi by 4. Now check f dash x is cos x minus sin x. If we put value from this interval, the value of x from this interval, we get positive value. Suppose 0 to pi by 4, there in between there belongs to pi by 6. You may put the value x is equal to pi by 6 in mind, and cos pi by 6 minus sin pi by 6, that will be always greater than 0. So function is increasing in this interval. And another interval is pi by 4 to pi by 4. It means pi by 4 to pi by, you may take any value from this interval, you will get that there is value less than 0. The value of f dash x less than 0. You may take any angle from this interval pi by 4 to 5 pi by 4. And if we get less than 0, it means function is decreasing in this interval. Now there is another interval, x belongs to 5 pi by 4 to 2 pi. 5 pi by 4 to 2 pi. Now check f dash x is equal to cos x minus sin x. If we take any value from this interval, you will get the value is greater than 0. So value is positive, and so the function is increasing. Thus we see that function is increasing in interval 0 to pi by 4 union 5 pi by 4 to 2 pi, and decreasing in interval pi by 4 to 5 pi by 4. Now there is a question number 8 from your exercise. Find the values of x for which y is equal to x bracket x minus 1 bracket whole square is an increasing function. Now you consider it y, differentiate it with respect to x, we get dy upon dx, and using power rule and then chain rule. Power rule will be 2 bracket x plus x minus 2 whole power 2 minus 1. Now d upon dx of x into x minus 2 according chain rule. So dy upon dx becomes 2x minus 2 d upon dx of x square minus 2x. So thus we get 2 bracket x minus 2 into 2x minus 2. So dy upon dx becomes 4x x minus 1 x minus 2. Now put dy upon dx is equal to 0. Thus we solving it, we get the values of x are 0, 1 and 2. Now represent these are numbers on number line. So we get possible intervals are minus infinity to 0, 0 to 1, 1 to 2, and 2 to infinity. There are 4 intervals, and among these we have to check f dash x. F dash x means dy upon dx. So take value from x belongs to, so from minus infinity to 0. So x belongs to minus infinity to 0. It means we are taking value less than 0, and less than 0, 4 is positive, but x will be less than, in case less than 0 it will become negative. X minus 1, because we are taking x less than 0, so it will be also negative. X minus 2 will be also negative. Thus we get first positive, negative, negative, negative. So result will be negative, which is less than 0. So function is decreasing within in this interval. Now take x from other interval, that is 0 to 1. 0 to 1 means fractional value. 0 to 1, less than 0 but greater than less than 1 but greater than 0. So we have a fraction. Now check dy upon dx. 4 is positive, x is fraction, and so positive. X minus 1 will be negative because 1 will be greater than the fraction, so it will give you negative sign. X minus 2 will be again negative. So thus we get the sign plus into minus into minus. The result will be plus, which shows that function is increasing in this interval. Now take another point from another interval. X belongs to 1 to 2. So dy upon dx becomes 4 into 1 to 2 means more than 1 but less than 2. So 4x will be positive, x minus 1 will be positive, x minus 2 will be negative. Thus we get plus into plus into plus into minus. So result will be minus. So function is decreasing within in this interval. Now fourth interval is 2 to infinity. So you take x belongs to 2 to infinity. So dy upon dx is equal to 4x, x minus 1, x minus 2. 4 is positive, x belonging to 2 to infinity. It means the values are more than 2. So 4 will be positive, x will be positive, x minus 1 will be positive, and x minus 2 will be again positive because the values of x are more than 2. So all are positive, so multiplication of all positive sign will give you positive, so it means function is increasing. Now you have to check, you have to find the increasing function and the values of x. So for increasing function, the values of x belongs to 0 to 1 union 2 to infinity from above. This is the solution. Now you have some assignments, you have to solve these assignments carefully. That's all. Have a good day. Thank you.